The paper delves into the industrial practices of requirements engineering, for machine learning, ML, enabled systems in Brazil. It reveals that 41% of Brazilian companies utilize ML to some extent, with several challenges reported, including unrealistic customer expectations and vagueness in ML problem specifications. The study aims to investigate the application of RE in developing ML-enabled systems in Brazil, focusing on current practices, perceptions, and problems in the Brazilian industry. The research methodology involved extracting and analyzing data from an international survey focused on ML-enabled systems, concentrating specifically on responses from practitioners based in Brazil. The analysis focused on the cluster of RE-related answers gathered from 72 practitioners involved in data-driven projects. The findings highlight distinct aspects of re-implementation in ML projects in Brazil. For instance, RE-related tasks are predominantly conducted by data scientists. The most common techniques for eliciting requirements are interviews and workshop meetings. There is a prevalence of interactive notebooks in requirements documentation. And practitioners report problems that include a poor understanding of the problem to solve in the business domain, low customer engagement, and difficulties managing stakeholders' expectations. The results provide an understanding of RE-related practices in the Brazilian ML industry, helping to guide research and initiatives toward improving the maturity of RE for ML-enabled systems. This study contributes to bridging the gap between complex research papers and concise, informative summaries for expert audiences. The paper explores the challenges and practices of requirements engineering, for machine learning, ML, enabled systems in Brazil, emphasizing the importance of RE in developing ML systems characterized by high experimentation and uncertainty. A survey of 72 practitioners involved in ML projects in Brazil reveals that data scientists often lead ML projects, and setting goals and requirements at the beginning can be challenging due to uncertainty. The study highlights the need to bridge the gap between theory and practice for maturity in ML systems. The authors of this research paper aim to identify the industrial practices of requirements engineering for machine learning-enabled systems in Brazil. They conducted a survey among professionals involved in building ML-enabled systems, focusing on demographics, problem understanding, and the requirement stage of the ML lifecycle. The survey design involved 4 steps: initial survey design review, pilot phase validity evaluation, and pilot content validity evaluation. The initial survey was drafted based on a literature review of requirements engineering for ML and previous results on RE problems and the RE status quo. The survey was then reviewed and adjusted by software engineering and machine learning researchers from PUC Rio, Brazil, and BTH, Sweden. The pilot phase validity evaluation involved 18 PhD students, resulting in minor adjustments to the survey. The pilot content validity evaluation involved 5 experienced data scientists, who provided feedback on the clarity of the questions and response time. The final survey consisted of 15 demographic questions, 7 questions on the ML lifecycle and problems, 5 on requirements, and 5 on deployment and monitoring. The target population comprised professionals involved in building ML-enabled systems, including project leaders, requirements engineers, data scientists, and developers. Convenience sampling was used, sending the survey link to professionals in partner companies and distributing it openly on social media. The data collection period was from January 2022 to April 2022, resulting in 276 responses, with 72 fully completed surveys from professionals working in Brazil. For data analysis, the authors used inferential statistics for closed questions, employing bootstrapping to calculate confidence intervals due to the unknown theoretical distribution of ML-enabled system professionals. The research questions concern the identification of challenges in requirements engineering for ML-enabled systems, including who addresses requirements, how they are elicited and documented, and the most critical non-functional requirements. The authors applied open and axial coding procedures to identify problems from OpenText responses, allowing the problems to emerge from the data. The survey questions and answer options were carefully crafted based on best practices of survey research, ensuring the validity and reliability of the results. Machine learning professionals in Brazil face significant challenges, particularly in understanding problems and defining requirements. The problem understanding and requirement stage is perceived as the most critical and complex phase of the machine learning lifecycle. This study investigates the experiences of 72 practitioners involved in data-driven projects across various industries in Brazil, representing diverse backgrounds and professional experience. The majority of participants come from large companies with over 2,000 employees, with most having 1 to 2 years of experience working with machine learning-enabled systems. The results reveal that data scientists, project leaders, business analysts, and developers are primarily responsible for addressing requirements in these systems, while solution architects, requirements engineers, and testers play a lesser role. To ensure robust statistical analysis, a bootstrapping technique was employed, providing insights into the characteristics of the Brazilian practitioners surveyed. The findings highlight the importance of effective problem understanding and requirement definition in machine learning projects, emphasizing the need for enhanced collaboration and communication among stakeholders. The demographics of the participants in the study are presented, including company size, main role, and machine learning (ML) experience. Figure 2 shows that most participants have 12 years of ML experience, with common roles being data scientists, business analysts, project leads, and developers. The perceived difficulty of each ML lifecycle stage is also explored, with model deployment and model creation being considered the most complex, while data collection and problem understanding are relatively easier. The study investigates how requirements are typically elicited in ML-enabled system projects, with interviews being the most commonly used technique. Requirements documentation is primarily done in notebooks, followed by user stories, vision documents, prototypes, requirements lists, and data models. Interestingly, nearly 17% of participants mentioned that requirements are not documented at all. The researchers also identify which non-functional requirements, NFRs, are critical in ML-enabled system projects, highlighting concerns around data quality, model explainability, and model reliability. Machine learning, ML, enabled systems pose unique challenges in requirements engineering, where understanding the problem and defining requirements are crucial for success. To investigate these complexities, a survey of 72 participants was conducted, exploring elicitation techniques, documentation methods, non-functional requirements, and the most difficult activities in for ML-enabled systems. Interviews and workshops were the most commonly used elicitation techniques, followed by prototyping, scenarios, and observation. Notebooks and user stories were the most prevalent documentation methods, with vision documents, prototypes, and requirements lists also being widely used. Non-functional requirements, such as system performance, maintainability, and usability, were considered critical by the participants. However, a significant number of participants reported that non-functional requirements were often overlooked in their ML-enabled system projects. The most challenging activities in for ML-enabled systems include managing customer expectations, aligning requirements with data, resolving conflicts, managing changing requirements, selecting metrics, and elicitation and analysis tasks. The survey highlights the main RE-related challenges in ML-enabled system projects, particularly during the problem understanding and requirement stage. The findings emphasize the importance of addressing these challenges to develop more effective ML-enabled systems, underscoring the need for a deeper understanding of the problem and well-defined requirements in ML projects. In Brazil, machine learning-enabled system projects face unique requirements engineering challenges. Practitioners struggle to understand the problem, manage expectations, and establish effective communication. Data scientists play a crucial role in addressing requirements, as they are predominantly responsible for this task. Elicitation techniques employed are similar to those in traditional software engineering, with workshops being more prevalent than previously reported. However, requirements documentation is primarily done using computational notebooks, with a significant proportion of projects neglecting to document requirements altogether. Non-functional requirements, such as data quality, model reliability, and model explainability, are considered, along with system-related concerns like performance, usability, and maintainability. The most difficult activities perceived by practitioners include managing customer expectations, aligning requirements with data, changing requirements, and selecting proper metrics. This study sheds light on the requirements engineering-related problems faced by practitioners in machine learning-enabled system projects in Brazil. While similar to previous studies, the challenges are distinct, with difficulties in problem and business understanding, managing expectations, and low customer, domain expert availability, engagement being prominent. In machine learning-enabled systems and traditional contexts, problem understanding and requirements elicitation face significant challenges. To address these, adopting established requirements engineering practices is essential, with a strong emphasis on empirical evaluations. However, several threats to validity must be considered, including instrumentation, inadequate explanation, failure to survey the target population, and bias in results. To mitigate these concerns, researchers were involved in reviewing the questionnaire, and it was piloted with PhD students and data scientists to ensure its clarity and relevance. Additionally, the target population was clearly defined in the consent form to avoid ambiguities. The reliability of the study is a key consideration, with the acknowledgement that statistical generalizability may be limited. Nevertheless, the use of recommended data collection and analysis procedures helps to ensure the trustworthiness of the findings. By acknowledging and addressing these methodological concerns, the study demonstrates a commitment to rigor and transparency, ultimately enhancing the validity and reliability of its conclusions. In the context of industrial practices for requirements engineering in machine learning-enabled systems in Brazil, significant variations emerge when compared to traditional systems. Despite these differences, underlying problems persist, including incomplete and/or hidden requirements, communication flaws, moving targets, underspecified requirements, timeboxing, and insufficient customer support. A notable trend is the increasing involvement of data scientists in leading requirements engineering activities, with interactive notebooks serving as a primary method for documenting requirements. The study underscores the critical importance of non-functional requirements, such as data quality, model reliability, and explainability, which are often overlooked in traditional systems. To address these challenges, the research proposes adapting and disseminating requirements engineering-related practices specifically tailored for engineering machine learning-enabled systems. This includes developing strategies to mitigate the complexities arising from the intersection of machine learning and requirements engineering, ensuring that the unique demands of ML-enabled systems are adequately addressed. By acknowledging and addressing these challenges, the study aims to improve the overall efficiency and effectiveness of requirements engineering in machine learning-enabled systems. This paper presents a detailed analysis of the challenges and difficulties in engineering machine learning-enabled systems, focusing on the Brazilian industry. The authors conducted a systematic literature review and interviews with practitioners to identify the main pain points in the development and deployment of these systems. The paper highlights several key issues, including the lack of understanding about machine learning technology among stakeholders, difficulties in specifying and validating requirements for ML models, and challenges in integrating ML models into existing systems. Additionally, the authors discuss the need for better collaboration between data scientists and software engineers, as well as the importance of addressing ethical and fairness concerns in ML systems. The study also explores the current practices and challenges in requirements engineering for ML-enabled systems in Brazil, revealing a significant gap between the academic research and industrial practices. The authors propose a set of guidelines and best practices to improve the collaboration and communication among stakeholders involved in the development of ML systems. Overall, this paper offers valuable insights into the challenges and opportunities in engineering machine learning-enabled systems, particularly in the Brazilian context, and provides recommendations for overcoming these challenges.